Hello there, FullSized here with another Rust Electronics video. Today we're going to be building automatic doors. Automatic doors can be really handy for a couple of reasons. First of all, they automatically open, so you don't have to. And second, they automatically close, so you don't forget. The outside door does open automatically when I'm moving out of the base, but I didn't think it would be a very good idea to have it automatically open when I'm going in. That said, if you want yours that way, you'll be perfectly capable of setting that up after we get done with today's build. First of all, I want to go over how the circuit works. Simply put, the HBHF sensor can be set to only activate when it detects someone who's authorized on the tool cabinet, which is how I have all of these set. The last thing we want is our doors automatically opening for an enemy. So when the HBHF sensor detects someone who's authorized on the tool cabinet, like yourself, it opens the door on either side of it. So as we travel down the hallway, the next sensor picks us up, opening the door in front of us, and the last sensor no longer detecting us closes the door behind us. How does it all work? Power input to this electrical branch is split. 2 volts goes to the HBHF sensor, and then the other 5 volts goes to this AND switch. The point of the AND switch is to boost the power from the HBHF sensor, as it only outputs 1 volt per person that it detects, and will frequently only be detecting one person, you. When the HBHF sensor detects you, it outputs the 1 volt that goes to the power input of this AND switch, and then that allows the 5 volts through the other input to travel through the AND switch. From there, it goes to the input of this electrical branch, and then the branch power goes that way. I'll show you that in a minute. And then the power output goes to this OR switch. From the OR switch, we have 2 volts coming in, allowing 1 volt to go to this door controller, opening this door. The other 2 volts from the branch power goes over here to the OR switch, controlling this door, and thereby to this door controller, keeping this door open so long as this HBHF sensor detects you. Furthermore, the other input from this OR switch, controlling this door, is coming from this electrical branch over here, so that it can open the doors on both sides of it, including this one. So, you just take this circuit and copy it over and over and over for as many doors as you have. The only exception, and we'll get into that a little bit later, is the first and the last door. This being the last door before you leave the base, you may notice there's no OR switch here. Now down here at this end, the last door also is a little bit of a special case. We do need the OR switch on this one, but we don't need this electrical branch, because that electrical branch that was there on this other circuit is responsible for sending power both to this OR switch and the next one down the chain. But there isn't a next one down the chain, so there's no point having the electrical branch there. It's just important to understand that your innermost door controlling circuit doesn't need the electrical branch, and your outermost doesn't need the OR switch. All of the rest of them can be set up exactly like this. And honestly, if you got plenty of high quality metal and you don't mind wasting a little bit of extra just to make it incredibly simple, you can build them all exactly like this. You'll just have one extra component on each end. So one last thing before we get into the actual build is our power system. Now I've gone over power systems in other videos. You're more than welcome to go check those out if you haven't seen them already. But simply put, you need to have a power supply. In this case, I'm using a creative generator that outputs 100 volts. I only need 50 volts of power generation. You could get 50 volts off of 6 solar panels, or probably a single wind turbine, even at low altitude. Regardless of your power setup, you want your power input to go to this first electrical branch. From there, you need one electrical branch for each door controller circuit that you're setting up, or for each door that you have. Each electrical branch should be set with the power output going to the power input of the next one. This takes all the leftover power that hasn't been branched off and moves it on to the next and the next and the next and so on. Your branch power out will then go to the power input of the electrical branch of each of these door controller circuits. Now, you could set each one of them to 8 volts. However, again, because of the special circumstances of the first one not needing an electrical branch, it only requires 5 volts. Furthermore, the outermost one that doesn't need the additional OR switch only has to be set to 7 volts. Without the OR switch there, it doesn't have that 1 volt voltage drop going through the OR switch and so it saves 1 volt. All of the rest of the electrical branches for all of the rest of the door controller circuits in the middle of your hall need to be set to 8 volts. You may also notice that I didn't put the HBHF sensor right here on the wall. The reason I didn't do it on this one is because if I did, it would detect me from pretty much anywhere in the base, and it would keep that door open. By putting it up here in this corner, it only detects me when I actually approach the door as if I were about to leave the base. I highly recommend not putting all of these electronics in your hallway. You should put those deeper in the base and simply run the necessary wires over. The only thing that actually needs to be in here is the HBHF sensor and the door controller. The only reason I set it all up like this is so that you can clearly see where each of the wires is connected to copy the build. So now that all that's covered, let's go ahead and build one section of this circuit. First, I'm going to remove all of these, including the door controller. And now we're going to place an electrical branch, an HBHF sensor, an AND switch, another electrical branch, an OR switch, and finally the door controller. Now, the first thing you want to do is pair the door. To pair the door, you hover over the door controller and press E. But if I do that right now, nothing is going to happen because the door is locked. In order to pair a door controller, the door that you're trying to pair has to be both unlocked and closed. This can actually be beneficial because if you had several doors, let's say I had a door on this wall and a ladder hatch up here, this door controller could reach and pair with any one of them from right here. But I can control which one I want it to pair to by simply opening or locking the ones that I don't want paired. It's only going to be able to pair to a door that is both closed and unlocked. So now that this door is unlocked, I can hold E while facing it, and the little green light turns on, indicating that it's paired. So now that it's paired, we can go ahead and relock the door. Now we need to go back over to our electrical branches and bring in some power. Just want to confirm real quick that this branch power is set to 8 volts, and then I'm going to bring some power over from that branch output to the power input on this electrical branch. Now your branch output you can leave set to 2 volts, which is the default, and run that to the power in on the HBHF sensor. The power out from the electrical branch can go to the input on the AND switch. Then the output from the HBHF sensor can go to the other input on the AND switch. Now again, what this is doing is it's boosting the power output from the HBHF sensor. No power is passing through this except when it's detecting someone who's authorized. Now at this point, we need to set up our authorization priority. Pull out your hammer and hover over top of the HBHF sensor and then hold down E. Then you have an option to exclude authorized, pick up, or exclude others. In this case, we want to select exclude others. That way, this HBHF sensor won't detect people who aren't authorized on the TC and therefore won't open the doors for them. The reason we waited until now to set this up is because you can't adjust that setting on the HBHF sensor until you provided it with power. The power output from the AND switch goes to the power input on the next electrical branch, and then the power out goes to the power in on the OR switch. The power out on the OR switch goes to the power in on the door controller. And then the door opens. If your door doesn't open right now, you've got a problem. Either something is hooked up wrong or you don't have enough power coming in. So, what about these other two terminals here? We've got the branch power out and the power input B on the OR switch. If this is the first part of the circuit that you set up, you can't really do anything with it yet. You've got to set up the next part. So once you build another copy of the circuit over here, exactly like before, then you can take the OR switch, power input B, and attach it to the branch power on this electrical branch. Once you've set up your circuit on this side, then you can do the same thing going the other direction. Take your branch power from this electrical branch and run it to the power in on this OR switch. So hopefully that made sense. You build this circuit once for each door that you have. Once you're done building at least 2 sections, then you can connect these other 2 wires. But inevitably you have to start somewhere, and so when you build the first section of this circuit, you're not going to have anywhere for this branch power to go, and you're not going to have anywhere for this input to come from. So just be sure that as you build each section, you go back and hook up the necessary wires to connect them. So that's it. Now all you've got to do is copy this for each door going down your passageway. Again, with the exception that on the last section, you don't need the OR switch. And also with the exception that on the first section, or the innermost section, while you do need the OR switch, you don't need this electrical branch. Well, that does it for today's video. If you enjoyed it, please like, subscribe, and all that good stuff, and we'll look forward to seeing you in our next video.